Black holes are incredibly strange entities. They defy all logic. Where do they even come from? And what happens when you fall into one? Stars are mostly made of unimaginably vast numbers of hydrogen atoms. Massive clouds of gas collapse under their own gravity. At their core, nuclear fusion fuses hydrogen atoms into helium, releasing enormous amounts of energy. This energy exists as radiation, pushing outward against gravity, maintaining a delicate equilibrium between the two forces. As long as nuclear fusion continues in the core, the star remains sufficiently stable. However, for stars vastly more massive than our Sun, the intense heat and pressure within the core enable them to fuse heavier elements, continuing until they synthesize iron atoms. Unlike the earlier fusion processes, the creation of iron atoms yields no net energy. As iron accumulates in the stellar core to a critical mass, the equilibrium between radiation pressure and gravity collapses. The core begins to implode. Within fractions of a second, the star undergoes a self-detonation, propelled at 1/4 the speed of light, continuously feeding more mass into the core. All heavy elements in the universe are created during this specific moment, after which the star dies in a supernova explosion. This may ultimately result in a neutron star, or if the star is sufficiently massive, the entire collapsed core may fall into a black hole. If you were to look at a black hole, what you would actually see is its event horizon. Anything crossing the event horizon must travel faster than light to escape. In other words, this is impossible. So we only see a dark sphere that reflects nothing. But if the event horizon is the black part, what is the whole part of a black hole? The singularity. We're not sure what it actually is. A singularity might have infinite density, meaning all matter is concentrated at a point with no surface or volume. Or it could be something entirely different. For now, we simply don't know. It is like a fraction with a denominator of 0. By the way, black holes don't work like vacuum cleaners sucking things in. If we replace the Sun with a black hole of equal mass, Earth wouldn't be affected, though we'd certainly freeze to death. What happens when you fall into a black hole? Time near a black hole behaves differently than usual. From an external perspective, as you approach the event horizon, time slows down for you. Time flows more gradually as you pass through. At a certain point, you appear as if time has frozen, your color gradually shifting toward red before vanishing. Observing from your own perspective, you would see the entire universe speeding forward, akin to glimpsing the future. Now, we don't know exactly what happens next, but predictions suggest two possible outcomes. 1. You die painfully. The black hole drastically warps space-time. Once you cross the event horizon, there is only one direction forward. Literally, inside the event horizon, you can only go one way. It is like a dead-end alley where each step you take makes the path behind you vanish. The matter in a black hole is intensely concentrated. From a certain point, even a gap of a few centimeters could subject different parts of your body to gravitational forces millions of times stronger. Your cells would be torn apart piece by piece as your body is stretched, until you become a stream of plasma just one atom wide. After crossing the event horizon, you'll rapidly collide with a wall of fire and be obliterated in an instant. Neither scenario is pleasant. How quickly you die depends on the black hole's mass. Smaller black holes might kill you before you even reach the event horizon, while supermassive ones might let you linger inside for a while. Empirically, the farther you are from the singularity, the longer you survive. Black holes vary in size. Some are only a few times the Sun's mass, with diameters comparable to asteroids. Others are supermassive black holes. One resides at the center of every known galaxy, having fed for billions of years. Currently, the largest known black hole is S50014+81, with a mass 40 billion times that of the Sun. Its diameter spans 2.367 trillion kilometers, 47 times the distance from the Sun to Pluto. Yet no matter how powerful, black holes eventually evaporate through a process called Hawking radiation.